our topic of statistics. Datum, that's the singular by the way, data, when we talk about data, it's a plural. So datum is a single quantity of some object or phenomenon. Data that we tend to look at, because one piece of data is not very useful, but we represent them with random variables. What is a random variable? It's simply a function. The value of that function is determined by the probability of the occurrence of that happening. Remember, random variables, they can be numeric, they can be categorical, they can be continuous if the range of answers has no break in it, I guess is an easy way of saying that. It's a nice continuous interval. Or it could be discrete, where there are breaks in there, they're countable objects. We look at descriptive stats. That's where we go collect the information and then we go present some summary of that data. And then once we've done that, the key part of stats really is this bit, the inferential, where we go and use it and analyse the data to make predictions and things like that about the future and make decisions. So let's talk about descriptive stats. They're the summaries. Visual, graphs, tables, data, charts. Quantitative are more our statistical measures. So like univariate data, where we look at central tendency measures, mean, median, mode, all those sorts of things, and spread, variance, standard deviation, range, interquartile range. Of course, there is bivariate data as well, and that's when we look at correlation, lines of best fit of the data, things like that. Our visual summaries, the frequency tables. Now, it doesn't matter whether it's numerical or categorical, we can create a frequency table. Let's have a look at this one. 20 students were asked how many pets they have. There's the result. We use tallies, and then we turn that into numbers and we get our frequency. Contingency tables, right? So two-way tables. Really good for conditional probability problems. So something like this. So we've asked for two pieces of information, both the gender and the eye colour. We want to know whether being male and having green eyes are independent of each other. That goes back to our probability. Remember we said A and B would be independent if the probability of A given B is the same as probability A. Well, probability of male then, if I just look at that one, we have 82 out of 167. But probability of male given that they have green eyes. So now all I'm interested in is the column of green eye. A male would be 20 out of 35. And no, they are not the same value. That would seem to suggest that being male and having green eyes are not independent of each other. Now whether that's valid or not, might have something to do with the sample size, things like that. Seems a bit weird, but that's what this data would suggest. Common graphs and charts that we've seen over the years. Line graphs, and there's our pet example in a lovely line graph. Column graphs, pie charts, sector graphs they're also known as. Bar charts, which is just a column graph fallen over. Dot plots, all sorts of different ways we can represent data. Then there's this thing called the Pareto chart. It represents, well, one idea is frequency of defects as well as the cumulative impact. So useful for something like this. Two graphs drawn together, we have a frequency histogram for the information arranged in descending order and a cumulative frequency polygon. Here is my example where shirts are being made, but there's certain defects, some with the button, some's the pocket, the collar, the cuff, the sleeve. That is how I would represent that information in a Pareto chart. So I have a frequency histogram or column graph going in descending order. The buttons had the most frequency, so there it was there, then the pockets, then collars, then cuffs, then sleeves, but then the line is the cumulative frequency polygon. And then we can read information off that. And on the left-hand side, we put the frequency. The right-hand side tends to be the cumulative frequency percentage. So why is it useful? Well, I want to eliminate the complaints I get about the defects in the shirts that's being made. Rather than focusing on all five things, this can quickly tell me that, hey, if I just focused on the buttons and the pockets, I'll get rid of 66% of the defects, so 2/3 of the defects, by just focusing on those two things. That's the idea of a Pareto chart. Quantitative summaries, the measures of central tendency, modes, which personally I think is not a great one, but in normal distributions certainly the mode will be dead in the middle, there's no question about that. The one that happens the most, so our example was one pet. It may not be unique, it is possible to have two modes, so bimodal, you could have trimodal. After that we just tend to say, oh look, it's multimodal, it has many modes. Median is better of course because that actually is finding the middle of the data. But treat it differently depending on whether you have an odd number or an even number. So if you have an odd number, the middle number will be the median. But if you have an even number, you've got to get the two middle ones and average them. So our example, there were 20 scores, which is an even number. So the two middle ones were the 10th and the 11th, we ended up with 1.5 pets. Remember, you've got to arrange them in order for that to work. Measures of spread. Range, highest minus the lowest. Obviously categorical data you can't find a range. I mean, what's the highest colour? Blue minus red. No, it doesn't make sense. You've got to have numbers for that one to make sense. So ours would be 4 pets. And that'll do us. Okay.